Welcome to lesson 2. Just like we did with lesson 1, I want you to pause the video right now and work on our skills maintenance. So work out these problems, do the best that you can, unpause it and see how we did. So the first ones, we're just adding and subtracting the fractions. Down here, max and minimum, you should hopefully already know. Max is the biggest number, min is the smallest. Mean is what we did on lesson 1, where we add them all up and then divide by how many numbers. Range and mode, you may or may not know. If you do know, give it a shot. If you don't know, you'll see in just a little bit. They're not very complicated. So pause the video and give these problems a try. So for activity 1, we've got common denominators with our fractions. So we just add the top numbers and keep the bottom number the same. If you remember, 5 divided by 5 should equal 1. Number 2, I do 4 minus 3, which is 1. The bottom number stays the bottom number, and I'm done. Number 3, the top number plus the top number, and the bottom number stays the same. Same thing with number 4. Number 5, I need to subtract the top numbers to get 7, and the bottom number stays the same. And then number 6, I add the top numbers together to get 25 over 10. This one does simplify down to 5 over 2, but like I said before, I need you to be able to get to all of these highlighted numbers. If you can get to that 1 and that 5 over 2, you're ahead of the game, and that's awesome. Okay, activity 2, tell the max, the min, the range, the mode, and the mean of the data. The max is the biggest number, which is 80. The min is the smallest number, which is 20. So the range, we didn't really talk about that before, but the range is maximum minus minimum. So I take 80 minus 20 to get 60. That's my range. My mode, I think most common. Which number showed up the most often, was the most common? 20 showed up 2 times, no other number showed up 2 times. So we've got 20. To find my mean, I have to add up 40, 20, 60, 80, 50, and 20. A column of zeros adds up to 0. I know 4 plus 2 is 6, plus 6 is 12, plus 8 is 20, 25, 27. So I've got 270. Now for my mean, I need to divide by, there was 1, 2, 3, 4, 5, 6 numbers. 6 goes into 2 0 times, but into 27 4 times. 6 times 4 is 24. Bring down that 0. 6 goes into 35 times. So my mean is 45. So even though we didn't have a single number that ended in a 5, our mean is 45. For number 2, our maximum is 20 and our minimum is 1. So again, our max minus min, that's what our range is. 20 minus 1 is 19. Our mode, which number shows up the most often? So 20 shows up once, 4 shows up once, 1 shows up once. That's how I keep scanning until I notice that 7 showed up 2 times. So our mode is 7. Okay, it's not always what number shows up twice. It's what number showed up the most often. If I had 2 numbers that showed up twice, I would have 2 modes. So my mean for this one, I need to add up 20, 4, 1, 10, 3, 7, 2, 8, 9, 6, and 7. Make sure you line up your place values. All right, so I'm just going to go from the top down to the bottom and keep counting. So 0 plus 4 is 4, 5, 5 again, 8, 15, 17, 25, 34, 40, 47. So 7 down, 4 up. 4 plus 2 plus 1 gives me 7. And there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So I take 77 divided by 11. 77 divided by 11 is exactly 7. So our mean and our mode in this problem were the exact same thing. All right, so today we're going to be talking about converting fractions to equivalent forms so we can add and subtract fractions with unlike denominators. Okay, so this video, there's going to be a lot of quick scrolling, so I apologize about that. But It is what it is. So previously, we had fractions like this, where we had a picture, we had 2 of the 5 things colored in, and we add in 1 more of the colored things, so that we've got 3 of the colored things, but there were still 5. So our top number changed, our bottom number stayed the same all of the time. Okay, that was what we did before. But that's not always going to work out so nicely, because if I have a picture like this where I have 1/2 plus 1/3, I do not have fair shares in these 2 fractions. So I can't just put them together. I can't just count them up. I don't know what this takes up. Okay, before I could count out all of those individual sections. So what we have to do is we have to find a common denominator. So we're going to start with a visual representation. We're going to kind of show what that looks like, and then we're going to show the algebraic way of finding it, which I personally think the algebraic way is going to be easier to understand, but some of us, I know, the visuals are going to be better. So we start by always visualizing a fraction bar. It represents one whole thing. Okay, if I look right now, I know 1/2 is right in the middle. Like if I had made another bar, 1/2, 2/2, I would represent the one whole. Okay, but I want to figure out what fractions I can have that match up with both the 1/2 and the 1/3. So like right now, I matched up, the 1/2 is right there, and then the 1/2 I want to cut into smaller pieces still, because I know 1/3 is smaller than 1/2. All right, so I cut it into 1/6 size pieces right there and right there. So there's going to be 3/6 that make up 1/2. But what's really, really nice about this, okay, well first, all of our fraction bars start at the same place. But if I look right here, they line up perfectly. So 2 of those 6s lined up to make 1/3. So I can actually use these fractions, because they're going to have that same common denominator on the bottom, and I can add like we did yesterday. So instead of 1/2, I had 3/6. Instead of 1/3, I had 2/6. If I add those together, top plus top is 5. Bottom plus bottom, I don't actually add, right? The bottom plus the bottom is the bottom. That number does not change. Okay, we're just adding the top number. Okay, the same thing works with subtraction. If I have 3/4 minus 1/2, I can break up my fraction bar into 3/4 and 1/2, and this one is pretty easy to see right away, that 1/2 is the same thing as 2 out of 4. Okay, if those 3 red things make 3 out of 4, 2 of them would make 2 out of 4. So then 3/4 minus 1/2 is instead 3/4 minus 2/4. Again, sorry, a lot of scrolling. So then to subtract, I just cross them off. I'm left with 1/4. Each of those rectangles represented 1/4. Okay, so when we make denominators the same, we also make equivalent fractions. We make fractions that are equal to the exact same amount. So now we're going to kind of show the algebraic way, which in my opinion is a little bit easier. Okay, we're going to use tables of multiples to find the common denominator. So what I would do is, if I'm trying to find the common denominator, 3 and 7, I'm trying to find a common multiple of those numbers. I'm going to list out as many multiples of 3 as I can think of right now. So 6, I should start with 3, I suppose. It goes 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. I just started counting by 3s. I didn't really have a specific end goal in mind, but I want to also find one of these numbers in the multiples of 7. So I'm going to count by 7 now. So 7, 14, 21. And then I'm just going to stop. Okay, if you notice, 7's bigger than 6, smaller than 9. 14's bigger than 12, smaller than 15. So I still kept them in a row, but I get to the point where I find 21 in both lists. So that is going to be my least common multiple. Okay? So if I got a lot of scrolling because they just wanted to go number by number. So the fractions problem that they're going to give us is 2/3 minus 1/7. Okay, we figured out that 3 and 7 both have a common multiple of 21. So this is what we're going to do. We're going to take 2/3 and we're going to multiply by another fraction. This fraction that we're multiplying is going to be the same number on top as it is on bottom. Okay? The reason it's going to be the same number on top and bottom is because if I have like 5 divided by 5, I know that's 1. And if I take any number times 1, I'm not changing the number. All right? Now, we wanted to get to 21. That was our key, right? 3 times what equals 21? 3 times 7 equals 21. So I'm going to do 7 over 7. When I multiply a fraction, I do top number times top number. So 2 times 7 is 14. Bottom number times bottom number is 21. This time the bottom number will change. All right? So this is what we just wrote out, the exact same thing. And then we have to do that with 1/7 as well. So 1/7, again, I'm trying to get to 21. So 7 times 3 equals 21. So I'm going to multiply top and bottom by 3. 1 times 3 on the top is 3. 7 times 3 on the bottom is 21. So instead of 2/3 minus 1/7, I can have 14 21sts minus 3 21sts. And then just like yesterday, I do top minus top, and the bottom number stays the same. I get 11 over 21. So I said this way, I personally believe is easier than that picture, but we're going to have to be careful, okay? Because when we're adding and subtracting fractions, if the bottom number is the same, I can do the adding and subtracting, but the bottom number won't change. If the bottom numbers are not the same, then I have to do some multiplying first. And the multiplying will change the bottom number, but I'm finding equivalent fractions because 2/3 in this case was equal to 14 over 21. I multiplied 2/3 by 1 and just made it unsimplified, if you want to call it that. So to make an equivalent fraction, multiply the numerator and the denominator by the exact same number. And there's another little example there. So if I want to get any common denominator, any at all, I have a kind of a cheap way of doing it. I want to get my least common denominator, so I have my simplest form and I've got the least amount of work to do. But if I just don't care about being simplified, there is another method that we can use where all we do is take the bottom number of this fraction times the bottom number of that one, and then similarly the bottom number of that fraction times the bottom number of the other one. So I don't like this arrow piece here. We're going to ignore that for right now. So if I have 7 over 10, I can multiply this by 20 over 20. 7 times 20, that's going to be 140. 10 times 20 is going to be 200. 3 over 20, I would then multiply by 10 over 10. All right, 3 times 10 is 30. 20 times 10 is 200, and I could have this problem right here. 140 over 200 minus 30 over 200. Well, 140 minus 30 is 110 over 200. That works, okay? But it is not our least common denominator, okay? Sometimes this is the easier method if you just want to get a quick answer and then try to simplify. But there is, in my opinion, a better answer. So again, I'm just going to kind of cross this off because I don't like what they're doing there. The better answer for this one would be to find our least common multiple. Okay, if I counted out multiples of 10, I would go 10, 20, and then I would stop at 20. Excuse me. So in order to get from 10 to 20, I need to multiply by 2. So I could have multiplied by 2 on top and bottom to get 14 out of 20. And then I wouldn't have to change that 3 over 20 at all. And I would be able to have a simplified answer of 11 over 20 instead of 110 over 200. Okay, so this is the simplified answer. This is another equivalent form. Again, with all of the extra scrolling and steps they want me to do, well, we've already done. They just wanted to have each little piece on its own slide, which is kind of obnoxious. So we've got a couple word problems now. So when we do a word problem, we want to read sentence by sentence and figure out what is important information. So this question starts off with, Hector rides his bicycle to school every day. It's good for him, but I don't really care all that much. Okay, he rides 2 1/3 miles down from Perry Street to Grove Street. Okay, math class, there's numbers in a sentence, it's probably going to be important. From Grove Street, he rides 1/4 of a mile to the school. Again, there's a number, it's a math problem, it's probably important. The question, always look for that question mark, is how far does he ride to school? Well, I know he rides this, and then he rides this to get to school. So if I want to know how far did he ride in total, I need to add those numbers together. Okay, so when I'm adding a mixed number and a fraction together, what I'm going to do is 2 plus 1/3 plus 1/4. I'm going to separate this 2 out and kind of just keep it along, but almost ignore it in a sense. I need to find a common denominator for 3 and 4. So off to the side, if I wrote out my multiples of 3, I'd have 3, 6, 9, 12, 15. My multiples of 4 are 4, 8, and 12. So I know I need a multiple, need to have my common denominator be 12. So 2 plus, well, 1/3 times, I went 1, 2, 3, multiple times 1 times 2 times 3 times 4. So 4 over 4 plus 1/4 times, I went times 1 times 2 times 3, 3 over 3. Top number times top number is 4, bottom times bottom is 12, top times top is 3, bottom times bottom is 12. When I add these together, I'm going to keep that 2 plus first. So 2 plus 7/12 equals 2 7/12 miles. Okay, so I should have an answer written as a sentence since it is a word problem. So Hector rides 2 7/12 miles to school. Okay, that would be my answer. The way I worded that is just looking back at the question. How far does Hector ride to school? Hector rides the distance to school. I use those same words. All right. So I went through that same problem. We already did it all in one place. So I can scroll past all of this stuff. If you want to look back later at it, it's in your OneNote, so you can look at that at your leisure. So now we got the next page in your workbook, which is this right here. Okay, it says find the least common denominator using tables of multiples, then circle the LCD and solve the problem. Okay, you've got a couple of problems there, and then you've got a couple more down here where each fraction you fill in the number that the numerator and denominator are multiplied by to find the equivalent fraction, then rewrite the problem and solve. I want you to pause the video and try those 4 problems, and then unpause the video when you're done, and you can see if you got the right answer. Okay, so for number 1 in this activity, I want to circle LCD. I'm going to highlight since I'm on the iPad. My LCD, the common multiple, is going to be 20. All right, so if I want to find 20, I needed to multiply 1/5 times 4 over 4 to get 4 over 20. And 1/4 need to be multiplied by 5 over 5 to get 5 over 20. So 4 over 20 plus 5 over 20 is going to equal 9 over 20. Number 2, I've got to fill in the table. So I'll go 2, 4, 6, 8, 10, 3, 6. And at that point I would stop because my multiple, my least common multiple, least common denominator, is going to be 6. Now I'm subtracting this one, so I got to make sure I'm careful. 1/2 in order to get to 6, 2 times 3, so times 3 over 3. That's 3 over 6. and then 1/3 I need to multiply 3 times 2, so times 2 over 2. 2 over 6, 3 over 6 minus 2 over 6 equals 1 over 6. So my answer to this question was 1 over 6. For activity 2, we're filling in all the blanks. So in order to get from 4 to 12, I need to multiply by 3. So multiply by 3 in the top as well. 1 times 3 equals 3. To get from 3 to 12 on the next one, I had to multiply by 4. So I have to put a 4 above there. 2 times 4 is 8. So to rewrite the problem, it was 1/4 plus 2/3. So now I'm going to have this number instead of 1/4 and this number instead of 2/3. So I'm going to have 3/12 plus 8/12, which is 11/12. 3 plus 8 is 11. On number 2, okay, in order to get from 3 to 9, I multiply by 3. So I have to multiply by 3 in the top as well. 2 times 3 is 6. On the next one, 9 times 1 gives me 9. So I'm not actually changing that one at all. So now I've got 6 over 9 minus 1 over 9. And that is going to equal 5 over 9. Okay, so that's the end of the notes. Make sure you're doing your homework. So go back to the homework section on OneNote. Literally says homework. You can't miss it. And then you're going to work on U1 L2. It stands for Unit 1, Lesson 2. That is your homework for this lesson. I hope everybody has a fantastic day.